Hello friends, today I am going to talk about the multiplexing. Mostly the multiplexing which is used to reduce the number of cables, because here in this diagram n number of input devices are connected with max. Okay, if it is analog or digital, it may be analog or digital, no problems, but we can able to share the analog or digital information through the single channel by using the max. Okay, because we no need to require more number of channels to transmit the signals. At the receiver side we connected the demultiplexers, because it will separate the individual messages by using the selective lines. Both the multiplexing side and demultiplexing side we have the selective lines which is connected with mux and dmux. Okay, for example, input side I'm using 4 input devices, output side I'm using the same 4 output devices. On input side, if I want to transmit the data from the first input devices to the third output devices. Okay, here totally how many devices I'm connected? Totally 4. So I'm using 2-bit selective lines. Okay, here I'm connected the 2-bit selective lines with the max. Okay, I'm going to transmit the message from the first input devices to the third output devices. The first input devices means 00, that is my selective lines. Okay, then if I select 00 selective lines, that the first device only can able to transmit the messages through this single line. Okay, that output side I'm using the same selective lines, and that output side also I'm having that individual selective lines which is connected with the dmax. Okay, here I'm going to select 10, then only the third output device connect with the dmax. Okay, so it can able to receive the messages from the first input devices. Now we are going to see the different types of the multiplexing signals. The first one, the frequency division multiplexing. The second one, the wavelength division multiplexing. The third one, the time division multiplexings. Okay, now I'm going to talk about the frequency division multiplexing methods. The frequency division multiplexing method means we are going to align different frequency to the different messages. For example, if I am going to transmit the first message means I will assign 100 hertz frequency, for example. Okay, for second message I'm assigned 200 hertz frequency. That is 200 hertz means that is a carrier frequency. We always know that the carrier frequency it should be higher than the message signal frequency level. So for each and every messages I'm assigning the different frequency. Okay, if I assign the different frequency means I can easily transmit through the multiplexing. At the same time I can easily demultiplexing at the receiver side. Okay, that is the secret of this frequency division multiplexing. Here I will tell how I'm assigning the different carrier frequency to the each and every messages. Here I'm having 3 carrier signals. The first one is F1. This carrier frequency is a low frequency signal, carrier frequency signal. That F2 is the high carrier frequency signal. Then F3 is very high carrier frequency signals. So I'm having 3 different range of carrier frequency signals. Okay, so I can able to assign these 3 different carrier frequency level to the different messages. After that, I combine these three messages, then I start to transmit through the multiplexing. Yes, here this is the first. Here I declared that baseband analog signal. That is the analog signal means that is the input signals. Okay, I'm having three input signals at the left hand side. Okay, the first baseband analog signal is combined with the carrier F1. Okay, after that the combination of that baseband analog signal plus the carrier signal is a modulated signal. Okay, then after that the second one, the baseband analog signal is combined with the carrier F2 signals. Okay, the same thing is going to happen at third carrier frequency signal also. After that I'm going to combine all the three modulated signals. Okay, then after that I'm going to transmit through the single channels. So I already told that what is the concept of the multiplexing. The multiple input lines into combined, the multiple input devices are combined, then after that it will transmit through the common channel. Okay, that is only happening here. Okay, this is the process of this frequency division multiplexing. At the receiver side, how I'm demultiplexing the signal. Here I already told each and every message is having different carrier frequency. At the receiver side I am using the diff band pass filter at the receiver side. Okay, by using that band pass filter I can easily separate the carrier frequency from the message. Okay, here the first filter I'm using for first filters I'm using to separate the first message. Second filter I'm using to separate the second message from the carrier. The third one I'm using to separate the third message from the carrier. Okay, at last I got the baseband analog signal. Okay, this is the operation of the frequency division multiplexing method. Okay, thank you for watching my video.